So standardization, I told you, is done to make sure that data that we are talking about are in similar range. Okay, they are in similar range. For example, in this example which I have here, you have salesperson, which is 2-digit number, and quotation, which is a 5-digit number. Right now, if I do not take care of it, if I do not take care of the values, the range of values, okay, quotation will have a impact, right? Or it will have higher weightage. Okay? Generally, you see that, right? I mean, when you have a larger value, your algorithm will tend to go towards that number. Okay, but when you're comparing two columns, you want them to have a equal understanding or equal importance, right? You want them to have equal importance, which you will not notice in this case, correct? So what we have to do is we have to bring them to the same level. Okay, so there are two methods. One is called min max normalization, and these are interview questions, and these are also your multiple choice question if you are appearing for any exam or certifications. Very popular question. So interview, what is standardization, right? Or why do we do standardization? Okay, or they'll give you a situation like this, and what analysis will you perform? What pre-processing will you perform? These kind of things will ask, can be asked, right? And interview questions will ask you which of these is a standardization technique or which of these are not a standardization technique. Okay, so two we follow. One is called min max, another is called Z normalization, or also called as variance scaling. Okay, min max, the value range from 0 to 1. So all the values that you have are kind of converted to range between 0 and 1. Okay, so that means, okay, if you take this value here, okay, 44, 27, 30, what is the minimum value? 27. So 27 will be converted to 0. What is the maximum value? 44. So 44 will become 1. 27 will become 0. 44 will become 1. And 30, based on the ratio, it will be something between 0 and 1. Okay. So here in quotation, 48 is lowest, right? So 48 will become 0. Okay. 72 will become 1. Okay. And this will be somewhere between 0 and based on the ratio. So there is a formula here. Each x, okay, so if talk about x, right? So each x is like x minus mean of x by max of x minus mean of x. So if I'm taking this column, okay, so this is my x value. I want to change this value. So this will be your 44 minus mean of this entire column. Okay, so 44 minus 27. Okay, divided by max minus mean, 44 minus 27, right? So see, 44 minus 27 by 44 minus 27 will get cancelled, isn't it? You will get 1.
1, yeah.
Correct? That's how you end up getting 1 for this. Okay. Now here, 27 minus entire mean value. So 27 minus 27. So you get 0 by anything is 0 only, right? That's how you get 0. And this will be 30 minus 27 divided by 44 minus 27.
Okay.
Okay. So 17 by 27, whatever, that will be the value for 30. This is what we do in min max. Okay. Similarly, you will do on here. So end of the iteration, you will have values which are between zeros and 1 only, right? So now there is no problem and you can continue building your mathematical modeling or whatever. So the idea here is, one, okay, we do not want any column to have a bias over another column just because of its size, volume, right? Second thing is, we we so one second thing is, so first thing what I said was not to have bias. That means between columns there should not be any bias. Second thing, but within the same column, we want to maintain that bias. Within the same column, We need to maintain that bias. So if 30 is there and 60 is there, 30 is half of 60, isn't it? So that has to be there. Okay. So that's why, okay, we are performing. So using this method, your values across the, uh, but if you're applying, you have to apply for all the numerical columns. Okay. Category columns is what you're doing in terms of converting into multiple columns, right? Okay. Encoding. But here you have to apply for all the numerical columns, right? So I'm applying converting numerical columns to these zeros and one. So the between columns, you won't be able to find any difference, but just by looking at it. But within the column, we are maintaining that relationship.
Yeah,
Okay?
means not changing the data as simple as.
Correct, correct. So meaning of data is not changed.
Yeah.
Okay. Data, of course, we are changing, but the meaning is not changed.
Yes, sir.
Okay. Or statistical meaning is not changed. Now, this is good, okay, when data is normal like this. But let's say if there is one outlier, 100 years, right? If there's one outlier 100 years and everybody is mostly like 20s to 40s, what will happen? 100 will become 1 and all this will be like closer to 0, 0 0.1, 0 0.01, 0 0.001, right? All most of this will be closer to zeros. So in a way, that is also creating a bias. So there the min max method doesn't work, where we have to go with the variance scaling or Z standardization, Z score normalization. But before we understand Z, this method, we have to understand what Z value is. Okay. So what Z value is? Okay. I told you most of the things in the world are normal. Okay. And machine learning algorithms concepts are also based on this thing, that most of the things are normal, right? So this is what we discussed other day, right? Positively skewed and negatively skewed. You have 0 here. So Z score is 0 here at the center. Okay. Now, you know how to calculate standard deviation now, correct? We calculated standard deviation, remember?
Yes, sir. Yes, sir.
Yes. So this is the 0, right? If you go one step, one standard deviation this side and one standard deviation this side, okay, and I'll tell you what happens. Then you can go 2 standard deviation this side, 3 standard deviation this side. Okay. Now, what does that mean? What does standard deviation mean here? So it's called empirical values. Empirical. Okay, let me first open that page and then I'll share. Empirical values. It's called empirical rule. Okay. It's called empirical rule. Okay. Okay. So this is an average, and as you go towards left or right, now since it's a like normal distribution, the distance that that you will travel on left side on the right side, it will cover same area, right? So this Z equal to 1 indicates 1 sigma, 1 standard deviation. Okay, so in this example, the standard deviation is 2. Okay, standard deviation is 2. So on this side 2 and on this side 2, this is called Z1. Okay, or what do you call 1 sigma. Okay, since we are on the right side, we generally call it as +1. Left side we call it as -1. Right? So this is your 1 sigma. Okay, and what is the area of this? You see this, right? It's not a perfect rectangle because this is not rectangle, correct? So the area of this area, this portion is called 1 sigma, and the value is 68%. This is also called as 68, 95, 99.7 rule. 68, 95, you have to remember this. Okay, easy to remember. 68, 95, 99.7 rule. Okay, so what does this mean? When you go 1 sigma here, 1 standard deviation this side, okay, and 1 standard deviation this side, okay, so this total area is 68%. Total area is 68%, or this is your 34% and this is your 34%. Okay, so between 1 sigma, probability in terms of probability is 68%. In terms of area, it is 68% area. In terms of values, approximately 68% values will fall under 1 sigma. So you can do that. You can take randomly 100 numbers, okay, and you see if you take 1 sigma and if you say, let's say, your mean is you took 100 values and mean came to, let's say, 68, right, and standard deviation came to 3. So 3 this side and 3 this side is what? Between 65 to 71, okay, approximately 68 values, 68% of the values will be there. So if you have 100 values, 68 values will fall under 1 sigma. Did you understand this? Then
Yes, sir.
you go 1 more sigma this side on the left and 1 more sigma on the right. Okay, so this is a 2 sigma. Okay, and what is the total area from here till here?
95%.
95%, yes. 95%. Now, how much is this area then? Only this area?
-95 minus 68 by 2.
I'm not a computer calculator. You're telling me, give me instruction and I have to calculate it for you. But you're right. Okay, just joking. Okay. Yes, you're right.
Yes.
It is 95 minus 68
Whole
because this is
divided by
95, isn't it?
Yes, sir.
I was only joking, Pujita.
Okay, sir.
Okay.
Okay.
So
13.5%, sir.
So this is your 95, sorry, 68. So 95 is total. 95 minus 68 will give us this and this, right? And these are equally distributed. So you get, so Pujita says 13.5, 13.5, approximately, okay? If you go by calculation, it will be 95.125 something, and it is 68 point something, okay? But on roughly, okay? You don't have to get in too much of into that actual value. So this is the 2 sigma. And 99.7, 3 sigma is 99.7. Okay. So now you tell me, what is this one? What is this area, Pujita?
1 second, sir.
What is this? 100 minus 99.7 is 0.3. 0.3 by 2 is 0.15.
Yes, sir.
Okay.
Yes,
So
sir.
this is your 0.15. So advantage is this. Okay. That's why, when you talk about the sigma, most of the things we stop at 3 sigma. Going beyond 3 sigma is like, time consuming, because anyway 99.7% of values will lie between 3 sigma. Why do we have to go beyond this?
Yeah.
Right. So this is your leftovers. If you take 3 sigma as a standard, okay, if you take 3 sigma as standard, this is your 0.15% of data. Okay, this again 0.15%, 0.15%. I mean, if you take 100 values, it is again negligible. If you take 1000 only, you'll get 1 value, 1 or 2 values here, or 1 2 values here, 4 values out of 1000, right? So what we do is we convert the values into Z score. So Z score is here 0, mean, when it is mean, it is exactly 0. Here it is +1, -1, okay, +2, +3, okay, -2, -3. So based on where your value lies, it will give us a Z score. Okay. And that is the value. So most of the values, if you see, if you do variance scaling or Z scaling, you'll see that most of the values will be between -3 and +3. Okay. It can be anything because we still have 0.115%, right? Which could be anything here also. So, but that is very negligible, right?
Sir,
Yes.
this 0.15% data are the outliers?
We assume it to be outliers.
Okay,
See,
yeah.
if you want, you can go out to four this thing also, right?
Okay, okay,
4 sigma also,
yeah.
right? If you go till 4 sigma, then whatever, like 0.00%. 4 sigma is what? I think 99.997%. 99.997. See, as you're increasing,
Yeah.
okay, it is become very much difficult to become accurate.
Yeah.
Okay. So so you'll have very less percent. So generally what we say is, we say, okay, we will take 3 sigma and values which are beyond 3 sigma we will ignore. These are like outliers.
Yeah.
So the point I'm trying to make here is, if we use Z score is not impacted by outliers. Z score is not impacted by outliers. We might, if we have outliers, that might be -6, -8, -9, it's falling under 10 sigma, like 1 in 1 billion kind of thing. Okay, let it be. Okay, but most of the values will fall under -3 and +3. We can continue doing our work. So this is called Z score normalization. Okay, and I'm going to share this. Okay, I'll put this here in that notes. And now coming back to our notes. Okay, the formula is x minus mean by standard deviation of x. So you have to calculate standard deviation of all the values in that column and mean of all the values in that column, and you will say x minus mean, each value minus mean. So see, if you get a mean value, okay, if you get a mean value, it is what? Mean minus mean, 0. Z score is 0.
Yes, sir.
Correct?
Yep.
This is how you end up getting
Z score.
Z score. Okay, and we anyway here here also we are using sklearn. Sklearn pre-processing. So pre-processing has, okay, scale value, okay, which will scale to the values that you want. Now tell me, looking at this, okay, which scaling would have been used here? You tell me. Look at the values and tell me which scaling is used here.
Okay, what he has done, you're asking?
Yes. Or what I have done here.
Zero mean and unit variance in the sense Z score, sir.
Why?
Variance, no, sir. You're talking about variance.
I missed to say that don't look anything before and after. Looking at the values.
Okay.
It is Z score because what did I tell you? What is the range of values in min-max scaling? What is the range that min-max scaling can take? 0 and 1 only, no?
Yes, sir.
In min-max, you will not have negative values.
Okay, okay.
And you will not have 1 point something, right?
Okay.
So you will not have values more than 1. Now, if you look at -0.8, clearly it is not min-max, it is Z scaling. Only 2 options are there, min-max and Z scaling.
Okay.
So it is Z scaling because you got a negative number. Okay, min-max will never give us negative number. They will never give us negative number. Now, if you just look at this data, then we can't say, right? It could be anything, that or this.
Yeah.
But negative numbers, 1.4, okay, minus 1.5, minus point. So these tell us that these are your Z scaling.
Yeah, yeah.
Okay. So when you use sklearn pre-processing and you say pre-processing.scale, okay, you just say scale and it will scale all your data frame or NumPy column rows. Okay. So it will do, by default, we do Z score, and that is what is preferred because that when you have thousands of data, right, you can't sit and look for outliers.
So
right?
machine learning itself takes the decision to
You
select
can
which
know,
scale.
min max is also there. So pre-processing dot min max is also there.
Okay, scale in the sense Z score.
Yeah, default scaling is Z score.
Okay,
Otherwise, you have to say min max scalar.
okay, sir.
Okay. So
Yeah.
dot min max scalar will do min max. You can choose, right? But we prefer Z scaling and we will do Z scaling only in our work.